Assalamualaikum and good morning to my panelists, Sir Nizam and Madam Leha. My name is Adli Hakim. I'm from course BEEE, and today I would like to present my Bachelor Degree Project 1, which is the development of digital timer controller by using IoT application. Firstly, I will show you the table of content for this project, which consisted of important and required information for this project. So the first point is about introduction, means about the background of the project, then the problem statement, the condition that need to be improved by the proposed project, and the next one is objectives, the project scope, literature review, which explain about some of the previous researches that compared and related to this project, and the next one is methodology, which explains the process flow of this project, and last but not least, what we can expect from the outcomes of this project. Okay, so we go straight to my first point, the introduction of this project. Nowadays, the mushroom industry had been growing every year in Malaysia and also including Indonesia and Thailand due to its demand. Mainly, mushroom farming or cultivation require attention or monitoring, especially on the control towards the temperature and humidity. A lot of ways and methods had been applied, such as developing an automatic system or fuzzy logic system to control the temperature and humidity to achieve to a desired level so that it can help in providing mushroom growth. So from the previous statement, it shows that the temperature and humidity is the parameter in determining the growth of mushroom. Some of the common components that were used in mushroom house in order to reduce the temperature and increase humidity were the water pump. But first, we need to know the condition of the existing temperature and humidity behavior in Malaysia, especially in UTM, as this project will take place at the mushroom house in FTKEE area. So, from the previous researches, it stated that the critical period of time occurred during 12 p.m. to 5 p.m. So, this is the period where the concept of timer will be used on the system process of this project in order to obtain the ideal growth of mushroom. And then, the most important part is the development and application of IoT to the project. So, the implementation of IoT platform will provide the user with the opportunity to remotely monitor condition and data in the mushroom through external devices such as smartphones or computers. Now we go to the next part, which is the problem statement. So the problem that were observed is that when there were no implementation of IoT on the system in the mushroom house, means that the user needs to do regular checking in the mushroom house from time to time because the user need to check the data of the temperature and humidity manually. Then the user also want to check the condition of the pump, whether it is turned on or off. So, all the process were done manually and involves a lot of human intervention. So, a previously proposed solution is that a timer device that can be purchased online or at a physical shop were used to solve the problem. It means that the user can set manually the timer for the pump to turn on and off automatically within the range of time set by the user. But then, the pump still not depend on the parameter of temperature and humidity to turn on and off. So the pump will depend fully on the timer that was set manually by user. Additionally, the user also still need to monitor the system locally due to the non-existence of IoT application to the system. Therefore, the proposed solution in this project is that the system will be implemented in applying smart timer to the pump with IoT application and will be added with the temperature and humidity data as the parameters in this project. Okay, to have a better understanding on this proposed project, we proceed to the objective for this project. So the project main objective is to develop digital timer controller by using IoT application. It means that the user can set the timer for the pump to turn on or off through smartphones. On the other objectives, it is to control and monitor the temperature below 30 degrees Celsius and humidity above 60%. So from the previous research, this is the parameter of the ideal environment condition for the mushroom growth. The data of temperature and humidity can also be monitored on smartphone by using IoT platform. Okay, so for the scope of this project, I will use Arduino Uno as a microcontroller in controlling all the components involved in this project, especially for DHT11, which is temperature and humidity sensor, and also water pump. Additionally, the Wi-Fi modules, which is ESP8266, will be used as communication between Arduino and mobile application that were developed using MIT App Inventor. So, the mobile application based on MIT App Inventor will be developed to display the data and information received from Arduino. So, the information will be including data from DHT11 that will be used to measure temperature and humidity around the mushroom house, and the water pump that will be used in supplying water to the area surrounding of mushroom house. So for the power supply, 240 volt AC that were inverted from solar battery is connected to AC water pump, and 5 volt DC supplied to the microcontroller. So the timer for water pump will be set on the smartphones that developed by MIT App Inventor. The next part of literature review, I will give an overview of the previous researches that can be compared and related to this proposed project. So the first research is by Amri, which conducted the system that takes place at the mushroom house. The paper also stated in controlling and monitoring the temperature below 30 degrees Celsius and humidity above 60% to ensure mushroom growth. The research also stated the use of Bluetooth module as communication between microcontroller and mobile application in providing monitoring system. The next research is about by Rohadi. So the paper conducted the system at the chili plant. The system used Raspberry Pi as a microcontroller in controlling the component and sensors involved. The data of sensors like temperature, humidity, wind speed, and light intensity from the Raspberry Pi is combined and compared with the Open Weather Map application to determine the condition of water pump. Additionally, the concept of timer is also used in this project. Next, the third research is by Camellia. So the paper also stated the use of soil moisture sensor as indicator or parameter in determining the condition of water pump. So the data of the soil moisture is displayed on LCD, which would then monitored in the website by using internet network. So how they use the internet network? They use the ESP8266 as a communication server. And for the last research is by Subedi. So the system is about an IoT based monitoring system for white button mushroom farming. So the system in this research used Node MCU as a microcontroller that were embedded with Wi-Fi module which can be used for IoT project. So the system is consisted of sensors like temperature, humidity and light sensors, which will then the data of this parameter sensor is monitored on Blink app, which is an IoT platform. Okay, now we proceed to the next slide, which is methodology. So this is the block diagram of this project. So the power supply that obtained from the solar energy, which converted into the battery and then go to the inverter to supply 240 volt AC to the water pump, and provided USB for 5 volt to the microcontroller Arduino. The DHT11, which is a sensor for temperature and humidity, will be connected to 5 volt Arduino, and its signal will be connected to the pin of Arduino. As for the water pump, it will be connected to the relay module 5 volt, which function to control the high voltage of the pump, and able to interface with Arduino by triggering the signal from the relay. As for the Wi-Fi module, the ESP8266 will act as a communication between Arduino and MIT App Inventor in transmitting and receiving data. So the MIT App Inventor will be the application where the visual process of the system can be monitored on smartphone. Okay, so for the flowchart of this project, as you can see, when the system is initialized, the Wi-Fi module ESP8266 will send data from the Arduino to the IoT platform, which is MIT App Inventor. Then, the data of the sensor and pump will be monitored on smartphone through MIT application. So, from this process, the water pump should turn on within the range time from 12 p.m. to 5 p.m. So, when the time reaches 12 p.m., the water pump will automatically turn on. So then the temperature and humidity data will act as the parameter in determining the condition of the water pump. So let's say for example, the temperature already reached below 30 degrees Celsius and humidity above 60% before 5 p.m. So then the water pump will automatically turn off. If the temperature and humidity still not reach the desired level, then the water pump will keep turned on until 5 p.m. Okay, so from this figure, this is how the circuit diagram should be constructed for this system. So as you can see, we have the important components and devices that connected. So like this, for example, Arduino Uno, ESP8266 Wi-Fi module, AC water pump, and DHT11. So this is the power supply from the solar battery, and this is relay module to control the high voltage of water pump and give signal to the Arduino Uno. And this is LCD to show the value and data of temperature and humidity. Okay, to conclude the presentation, what can we expect from the outcomes of this project is that the temperature and humidity can be controlled and monitored to the optimal level, which is the temperature below 30 degrees Celsius and humidity above 60% in order to ensure the mushroom growth. Additionally, the concept of timer is able to be applied in controlling the water pump. As stated previously, the critical period of environment in Malacca, especially UTEM, is happen during 12 p.m. to 5 p.m. Most importantly, the IoT application for this project able to be developed in order to achieve automated control and monitoring system for the mushroom house. So this is the references for the previous research that were compared and related to this project. And lastly is the Gantt chart. So this is the project planning for my bachelor degree project 1 in the whole semester. So lastly, thank you for your cooperation in listening to my presentation.